Beccalynn. Today we're going to talk about science. We're going to talk about anatomy. And this is my friend Esmeralda, and she's going to help me talk about the digestive system. So, you know that your body is a wonderful and beautiful machine, and it has many different organ systems that work together to keep an even balance all the time of gases and temperature and energy and strength and health, along with things that we don't need. So this careful balance is called homeostasis. Today, in talking about the digestive system, it starts with your mouth and it ends with, well, where things come out. But I'm not talking about the liquid things that come out. I'm talking about the solid things that come out. We'll talk about the liquid things another day. So let's start with this journey with this fantastic looking strawberry. Esmeralda takes a bite and she uses her skeletal muscles in her face to chew with her teeth, but she's also got her tongue moving it around, and she also has glands in her face, salivary glands that are squirting fluid into her mouth that have enzymes that are breaking down the food and changing the strawberry into something that is called a bolus. And all of a sudden, it feels kind of like a gooey, bally paste. So this bolus all of a sudden isn't a strawberry anymore. It's this thing, and it's in your mouth. And what does your tongue all of a sudden want to do with it? Well, it wants to swallow it. But wait a minute. We can breathe through our mouth and we can swallow. So how are we going to figure out, how does our mouth know where the food goes? You know that little dangly thing in the back of your throat? The epiglottis? The epiglottis is a little door and it shuts your windpipe so the food doesn't go into your lungs. Bet you didn't know that. So your epiglottis closes your windpipe and you swallow the strawberry bolus into your esophagus. We masticated our food. And we chose to use these muscles, just like I'm choosing to use these muscles to talk. Our smooth muscle in our esophagus is involuntary. It just has its own program that does its own thing in its own time. And it's programmed to move food down using peristatic movements, so little contractions. So it squeezes the food down, the bolus down, and it only goes in one direction. Did you know that? It moves the bolus down towards your stomach. Unless that food gets down into your stomach and the stomach says, there's some bad bacteria in this food. This food needs to go back where it came from. Then the stomach tells your esophagus to reverse engines, and that peristatic movement, those muscles, start contracting and going back up, and all of that food comes back out and vomiting. And it will keep vomiting until all of that peristatic movement will keep being reversed until the stomach is satisfied that all of the bad bacteria is gone. But our strawberry is perfect. It's a perfect little bolus moving down Esmeralda's esophagus, and now it has plopped through a sphincter, which is a little door right at the top of the stomach that is triggered when we swallow. And it's closed all of the time unless we swallow. So it plops into our stomach, a little sack. Kind of. It again is made out of smooth muscle. Again, it has this whole involuntary system. I don't have to think about making my stomach move. It has its own program. It uses the same kind of peristalsis movement, but this time instead of massaging, it's churning. It's massaging, it's moving all of that food around, and it's also got glands in the stomach. So it's squirting water in there, and it's squirting acid in there, and it's working enzymes, and it's breaking the food down, and now it's not so much of a bolus, it's now turning into chyme. and it's turning in. Once the chyme is now ready for the body to absorb, it's now all liquidy and watery and ready to go, it moves in through the pyloric sphincter into the small intestine. You see my little happy small intestine with the great big happy eyes? So it's very twisty. Again, it's made out of smooth muscle. It has glands. And would you be surprised if all of this purpley bit that you can see that's spinning round and round and round, if we stretched it all out, all inside of ourselves, we stretched it all, it would be 6 feet tall. The strawberry chyme now is moving around, and there are more enzymes, and there's a little more stuff happening. There's some bile from the liver going in there, and there's some good bacteria happening in there, and it's breaking it all down as it moves through the small intestines. And the fun thing about the small intestines, even though it looks all twisty-turny and where's the end and where's the beginning and how can this all work and how can this be a good thing for our body? Well, inside the amazing small intestine are these finger-like things called villi. And on the top of these villi are microvilli. And they are out there hanging out in the chyme with all of the enzymes and everything. So now that everything's broken down into its elements, down into its chemistry, these microvilli have epithelial cells on them. And so these epithelial cells are kind of like doorways. And so what they do is they grab nutrients from the strawberry chyme that's swirling around in our small intestine, and they're grabbing the nutrients and they're pulling it out and they're putting it in the bloodstream so the bloodstream can take it to where it needs to go. If it's the vitamin C helps our immune system. Whatever we need for homeostasis, whatever station that blood needs to go, then that's what this gateway, this epithelial cells on this microvilli are doing as they are fishing through this chyme in our small intestines as it's going round and round. So by the time that it goes round and round and round and round, by the time it gets to the end of the small intestines, all that's left is indigestible food or waste. Body doesn't need it. So it's all gathered at the ileocecal valve, where the valve is in between the small intestine and the large intestine. So it goes through this ileocecal valve into the large intestine, and then the large intestine, which basically is just a great big loop around the small intestine, right? And it's called the large intestine because it looks a little bit bigger than the small intestine. And so what the big intestine does is it starts to absorb the water out of the indigestible food, the waste, the stuff that our body doesn't need. And so again, this is soft, this is smooth muscle. We don't need to tell it what to do. I don't need to decide to tell my large intestine to do its job. It's just doing its job on its own. And it's moving through the 3 parts of your large intestines, which is your cecum, your colon, and your rectum. So in our blue that you can see wrapped around our small intestine, all the water's being sucked out. And as it gets to the end, which is your rectum, that's just kind of the waiting station where it's just kind of packing in there at your rectum. But the rectum isn't the final stopping place. Did you know that? There are 2 sphincters. One is voluntary, the other is involuntary. The involuntary is just kind of holding everything there until there's enough for you to let go. And the other one is Uranus, the one all the way at the bottom. So when you've got enough for yourself to go and you start feeling a little uncomfortable and you need to go, then we all go. 2 questions from my classmates. What is the little dangly thing in the back of your throat, and what is it called? Yep, the epiglottis, and it keeps food from traveling down your esophagus. Second question. Do you remember what the smooth muscle movement is called that gets the food around your body? That's right, the peristatic movement. Excellent job. Today, my resources were the